Hey, everybody, welcome to episode 132 of the Metal Detecting Show podcast. My name is Ciaran, and I have been metal detecting for the last 30 years. This week, we chat about some minor drama, some storm in a teacup that has occurred on the internet, on YouTube, all about Minelabs' claim for 50% improvement in delivered power. So let's get on with the show. You might be privy to this information or you might have partaked in this information, but you definitely should be aware that there is a little bit of a kerfuffle online right now between Minelab and the community around Mark Laurie's statement around how they can deliver 50% more power than the Equinox into the ground. Now, I, for one, I'm not disputing this fact. I just want to put it out there. But why am I weighing in on this? Well, I've seen a bit of conversation or a bit of drama, storm in a teacup, whatever you want to call it, on YouTube, on the forums about this. And I really feel strongly about the level of misinformation that is out there around what the FCC does, around what and how an actual metal detector works, and about the speculation on how they can actually deliver this. So this is more about scratching my itch around the frustration on this. And if you've liked the Metallurgy series to know, and we will return to normal service next week, picking up on copper for next week. So listen, let me just have this little foray into the drama and put my 2 cents into it, put it out there in the public, and hopefully I can address quite a few of these comments out there, and hopefully you as the listener will be better informed and better able to voice your opinion with knowledge backing you up. So let's get on with it. But first, I want to make a statement of fact. I have been a huge fan of Minelab in the past. However, I have called them out on several times Minelab's artistic license when it comes to spin. And a lot of people are jumping on that as well, saying that the Manticore's ability to deliver 50% more power into the ground is spin. Quite a few of these people, like me, have not even used the Manticore, so I'm actually not going to base anything I talk about real world experience with the Manticore. I'm actually going to base it upon my understanding of how a metal detector works, my understanding of what the FCC do, and we're going to get into the weeds around Maxwell's 4 laws around electromagnetism. So I'm trying to base my opinion on some level of science. So full disclosure, I am a Minelab fanboy. In the past, I've been critical of their marketing technique, and I do not own a Manticore, so take whatever I say right now with a pinch of salt. However, I am basing it all on sound knowledge and sound scientific principles. So I'm going to start at the very beginning, because at the very beginning, a lot of these arguments are being based on the fact that people assume a metal detector is like a radio, or is essentially a radio that transmits waves into the ground. This interferes with a metal target, and this creates eddy currents in the target, which is picked up by the receiving coil on a metal detector. Now, that's an analogy that's put out there. I've used it myself to keep it very simple when explaining to people how a metal detector works. That's not actually the reality and how a metal detector works. In the past, I did elaborate and talk about induction and how eddy currents are set up in the target volume, but I never went into the following detail on how an actual metal detector works. And I think it's important, particularly for this argument, that you understand how a metal detector works. So firstly, your metal detector is not a radio. It doesn't transmit anything. It's what technically is called an LRC circuit that is in balanced resonance. What does an LRC circuit mean? Well, L in the circuit is inductance, which is normally a coil. Think about it, a coil. R is resistance. We talked about resistivity before, so it's the same thing. It's a metal's ability to resist current. And then you've got C, which is a capacitor, which is essentially like a bucket, which holds charge and releases it at a steady rate. Okay, so a metal detector is actually an LRC circuit, right? And when you push an AC signal, that's an alternating current signal, through an LRC circuit, you set up what's called a low frequency reactive magnetic field. So a metal detector is essentially a low frequency reactive magnetic field generator. Okay. Now you're going to say, but Ciaran, a metal detector has 2 coils. It does. And this is how the metal detector piece works. So you have 2 coils, and because you have 2 coils, you have 2 LRC circuits, or two low frequency magnetic field generator circuits. Because the two coils are close to each other, a mutual inductance is set up in each of them. This mutual inductance is sometimes called magnetic coupling. So these coils, or these LRC circuits, are then tuned so that the capacitor and the resistance basically cancel each other out. What happens then is that your circuit is drawing the maximum current, or Imax. And when a circuit is drawing Imax, it essentially sets itself up in resonance. But because both circuits have been tuned, they're actually set up in resonance with each other across this magnetic coupling across the coils. So you essentially have what is a balanced seesaw between these two currents. So they're perfectly balanced. And then when you wave your coils, both coils, over a metal target, this induced field, because it's an AC signal, this is a field that's doing a lot of work. This work then sets up eddy currents within the target. And these eddy currents are also an induced field. And when this induced field comes in contact with your balanced induced field with your metal detector, it tips that balance. And then that in turn triggers the alert in your metal detector. And to what degree that balance gets tipped indicates what type of metal it is. By the way, a brief aside here, the AC current frequency, so AC is a sinusoidal wave, and the frequency of this AC driving current is the frequency that you select in your metal detector. So 7 kilohertz, 40 kilohertz. That's where your frequency piece comes from. So to recap briefly, you have two LRC circuits which generate a low frequency magnetic field each in each of the coils. Those two coils, because they're in close proximity to each other, set up mutual inductance, sometimes called magnetic coupling, in those two coils. When you wave these coils over a metal target, because it's a working AC signal, that produces eddy currents in your metallic find. Those eddy currents in turn then produce its own low frequency magnetic field, which then tips the balance of your metal detector, alerting you to that there's metal underneath the coil. And that's how a metal detector works. But if you're more interested in getting into the weeds on how an actual metal detector works, I recommend you go check out Walter Lewin's physics lectures on YouTube. He has a whole physics course there that you can check out. So it's not a radio and it's not a transmitter. So why does it need FCC certification? Well, what does the FCC do? So the FCC regulates and monitors international communications by radio, cable, TV, satellite, anything that has to do with non-governmental use of the electromagnetic spectrum. So why would the FCC be involved in a metal detector? Well, the FCC also regulates whether an electrical device interferes with surrounding electrical devices. So it has to get certification to ensure that it is not bleeding off any dodgy radio waves that could trigger your pacemaker, for example, or anything like that. Okay. So the FCC ensures that the interference coming off any electrical object ever doesn't actually induce any interference in other electronic equipment. So that's the two things the FCC are responsible for. And I just happened to look at the FCC certification for the Minelab Manticore. And you can check it out yourself. So its FCC ID is Z4C0049. And when I looked into the FCC certification for the Manticore, all it refers to is, think about it, we're talking about communication here. What does the Manticore have? It has Wi-Fi and Bluetooth, which it uses to communicate with your headphones. And it only refers to Bluetooth and Wi-Fi connectivity with your headphones. So why is there a 1 watt limit from the FCC on a metal detector, for example? Well, everything comes under this 1 watt limit because you're allowed to broadcast under 1 watt, which is minus 30 dB. And we're going to get into the decibel scale now in a second as well to dig into that. Right, so it's minus 30 dB, which is equals 1 watt. So as a citizen of the world, and according to the FCC, you're allowed to communicate or use an electronic device to communicate less than 1 watt. All that is saying on the Minelab machine is that it's communicating at less than 1 watt. It has nothing to do with the transmission power of the coil. So the FCC minus 30 dB has nothing to do with your metal detector's power and the power it delivers into the ground. I think a lot of people misunderstand what a metal detector is, and I hope my previous explanation explains this. But a lot of people use the analogy that it's a transmitter. So I'm not going to use that analogy anymore. I'm going to say a metal detector stands up a wave underneath its coil, like a big bubble hanging off the bottom of your coil. It's not actually transmitting anything off it. A brief aside, actually, if you look, I'll include a clip here. If you look at the actual certification, there are several references by Minelab to the Manticore's block diagram. However, when they reference the Manticore's block diagram, they actually call it the Sirius, SIRIUS block diagram. It's referred all across the document. So I'm wondering, was Sirius a secret code name for the Manticore within Minelab? And maybe Minelab can comment and let me know if I'm barking up the wrong tree there. So a brief interlude into what decibel means. A decibel is either the measure of noise or sound intensity or noise intensity. It can be used for gain. It's used in a lot of measurements. But what is key about a decibel is that it's a measurement on a logarithmic scale. What's a logarithmic scale? A logarithmic scale is a scale designed to cover a large range of information on a very small scale on a graph, for example. Not linear. It doesn't go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Think of it like a slide rule. If you have old enough to use a slide rule, you'll understand what a logarithmic scale is. It doesn't have equal distance between the parts. And because of this, minus 30 dB obviously equals 1 watt, right? But if I was to reduce a 30 dB signal by 50% or to increase it by 50%, I wouldn't be going to 45 dB. I'd be going to 33 dB to increase it by 50%, or I'd be reducing it by 3 minus 3 dB, so to reduce it by 50%. So simply looking at the numbers and expecting them to add up based on a linear scale is also incorrect in making assumptions around this 50% power delivered to the ground. So it doesn't even factor into the Minelab's discussion around the 50% power improvement into the ground. How do I believe they're delivering 50% power increase into the ground? Well, to do that, you have to look at some of Maxwell's 4 calculations around electromagnetism. Starting with the Lorentz force. This is a force a particle experienced when exposed to an electromagnetic field. And when you take power current into the equation equals F, which is the force, Lorentz force, equals I, which is current, L is the length of the wire, and B is the magnetic field in the wire. So from the Lorentz calculation, you can see that the current and the length of the wire is super important. But let's look at another one. Let's look at the Ampere circular law, which describes the retractive or repulsive force between two wires carrying an electrical current. And the equation is B, which is obviously the magnetic field, which we talked about, mu 0, which is equals to the magnetic permeability of air, I is the current, again in amps, and R being the distance from the wire. So as you can see, the current and the length of the wire, again, is super important. But let's look at Faraday's law, which is also part of Maxwell's 4 laws of electromagnetism, which states in a closed coil or loop of wire, a change in the magnetic field produces either a change in the voltage or a change in EMF, electromagnetic force, and then the change over time. E equals the number of turns times the magnetic flux of the coil divided by the change in time, okay? We don't need to get stuck in the weeds in it, but you can see the number of coils in the wire or the length of the wire and the magnetic field are interlocked again, right? So even just looking at these 3 equations, you can see that the current, the length of the wire, and the number of turns in the wire are super important to the size of the magnetic field produced by the coil. So if Minelab are saying they've increased the power delivered to the ground by 50%, it can only mean one or all of these 3 things. 1, they've increased the current into the coil. 2, they've increased the length of the coil. Or 3, they've increased the number of turns in the coil. All those 3 factors limit the size of the magnetic field under the coil. So if they're saying they've increased the power into the ground, it can be either they've increased the current, indicated by the word power, or they've increased the size of the magnetic field, which they do by increasing the current anyway. the length of the coil or the number of turns in the ground. It's pretty simple when you look at the equations, right? So did they need to break any FCC regulations to do this? No. No, of course not, because it's not a radio and it's not a communication device apart from the headphones and Bluetooth. So what does this 50% increase actually give you? So to understand that, we have another equation. You have to look at the inverse square law, which measures the intensity of a point source based on your distance from that source. Intensity equals power divided by 4 pi r squared, where power is the power of the source, pi is pi, and r is the distance you are from that source. Let's make some assumptions first before we do the calculation. So let's assume you're a good tight detectorist and you keep your coil a steady 5 centimeters above the ground, which is 2 inches. That assumes then that, just for argument's sake, that the magnetic field can reach another 30 centimeters or 12 inches into the ground. Okay, so that gives you a total of 35 centimeters. Let's also assume that the power in this situation is about 300 milliwatts. This is just an arbitrary number to help with the explanation, but let's just assume it's 300 milliwatts and let's plug all these numbers into the calculation, okay? So using the inverse square law, which is, again, intensity equals power, which is our 300 watts, divided by 4 pi r squared, r being our distance of 35 centimeters, okay? So it's 300 divided by 4 pi 35 squared. 35 squared is 1225. So it's 4 pi multiplied by 1225, which is 15393. And then you take all this and you divide 300 by it, and that equals 0.194 intensity at 35 centimeters. Now, let's say Minelab have increased the power by 50% into the ground. So let's up our power by 50%, which brings it to 450 milliwatts, and do the same sum again. So that's 450 divided by 4 pi 15393, which is equal to 0.292 at 35 centimeters. So you can see they've increased the intensity of the field from 0.19 to 0.29 with a 50% improvement. So you're not getting a huge improvement on it, right? But what does that actual increase mean from a distance point of view? Let's just pick a distance. Let's increase the distance by 2 inches or 5 centimeters. So going from 35 centimeters squared to 40 centimeters squared in the calculation, that gives us 450 with the 50% power increase divided by 4 pi 40 squared, which is 1600. And then multiplying that by 4 pi gives us 20,106. So 450 divided by 20,106 equals 0.022 at 40 centimeters. So you can see it's quite close to 2 centimeters actually. So 0.19 from original to 0.22 intensity. Now, this is all arbitrary, guys. This is all just back of a fag box calculation, so don't take it for gospel. But that 50% improvement should light up the ground quite a bit more, and potentially could give you 2 extra inches into the ground. Now, in reality, will it give you 2 extra inches? No, of course not, because you need to account for the permeability of the material that the magnetic field is passing through. So you won't get 2 inches, but you definitely will get an improvement. You definitely will turn up that light into the soil a little bit more. So is a spin? I actually don't think so. I think when you run the numbers, it actually looks quite possible, and quite a simple improvement to be made. And that doesn't account for any of the algorithm software either. So from my point of view, is a spin? I don't think so. And I think I've gone a fair bit down the road to disprove or to create another voice out there around the discussion around how they could do it. It is what it is. I tried to use some maths, I tried to use some science. I looked at the FCC report and I tried to understand how a metal detector actually works. I hope you now are better equipped to understand how a metal detector works and how Minelab could increase the power into the ground and actually have hard, I suppose, science. And I'm not going to dispute Maxwell's 4 equations for electromagnetism to help prove that point. So listen, I hope you like this episode, and I hope I was able to shed some light onto the discussion that's happening online. And in doing this exercise, does this make me want to purchase Manticore. It probably does, to be honest. It makes sense to me now. I'm still torn between the Manticore and the DS2, so I'm just waiting to see what the general vibe is on both, because I am a careful purchaser as well. I'm not going to rush out and buy one straight away. However, if Minelab want to send me one for this public service I've just done for them, it would be nice, to have a test unit for me to check out. So, anyways, guys, let's just leave it there. Thanks for listening to the podcast this week. Thanks for watching on YouTube if you're watching on YouTube. If you don't like how I look, you can go over to any podcast directory of your choice. Like and subscribe over there as well. Leave me a review, guys. Leave a comment. We'll get back to normal service next week, where we pick up where we left off on our metallurgy series and we talk about copper. And I also have a few questions for Dr. Detector next week. So that's it, guys. Good luck. Get out there, eyes down, and happy hunting. Unlimited power!